In this video, I'm going to be talking to you about containers. I'm going to introduce what containers are, what benefits they give you, and why you could consider using them. During my Homelab journey, I was consistently seeing the word Docker, container, podman, and I was in that position whereby I set up my virtual machines, much like in the last video. I had a number of applications running on those, but I was pretty much operating an application per VM situation, which just isn't scalable. So I thought, what's the next step? I really should learn containers, and that's what I'm going to share with you today. So what is a container? It's pretty much what you have in mind, what you would think of physically. It's an application that is self-contained, i.e. it is something that you can deploy onto a server that serves a specific function. An example could be a web proxy, something like Nginx. You could have a web server, something like WordPress. You could have a game server, something like Minecraft. What it is an application stripped down to its bare fundamentals. The beauty of this approach is that the image size can be very small. The application will depend upon files being made available on the operating system. So, with each container, you don't have to deploy all of the underlying code, operating system, etc. It has access to those host files as and when requested. For instance, the Alpine OS, that is a Linux distribution, is only 5 megabytes in size as a container, yet it functions as a full operating system within a container. So hopefully that spells out one of the first advantages of containers, is that they're lightweight. That alludes to the second benefit, in that they are ephemeral. So that means they are short-lived and typically shouldn't have persistence. That means if you create a container and you do some work on it, if you redeploy, restart that container, that data is lost. So you might be thinking, that seems like a pretty bad design. Why would I want to use this? Well, you can overcome that issue by having something called persistence. This is whereby you mount a local file system or a network storage solution to the container. That means that it has access to persistent storage when required. Typically, you would do this for only the parts of the container where the content needs to change. For example, on an Nginx or a web server, you would change or mount the folder structure for where the web files are hosted from. All the rest of the deployment can be ephemeral. That means you can destroy that and the data remains on the host secure. Then, if you needed to spin that container up again, even if you needed to do it on another system, as long as it had access to that storage, you would get the same output. Which leads us nicely onto the next one, which is repeatability. The beauty of containers is that they are governed by code in terms of a deployment. So you can be confident that each time you deploy that container, you are going to get the same output. So, again, much like a virtual machine, removes that sort of dependency on the underlying hardware and gives you a consistent operating system. Containers do the same for applications. Another benefit to containers is security, provided that you configure them correctly. And we'll touch on that in subsequent videos. But in theory, a container is isolated in its own environment. This creates segmentation between applications and reduces the likelihood of compromise. Furthermore, containers make it simple to run applications under different users, much like you would do on a base operating system. So if you take the lessons learned from our previous video, whereby I outlined why a virtual machine is a good idea, because again, it creates another kernel that isn't running on the host's kernel. Containers run in a similar fashion. So not only if you deploy it on a virtual machine will you get that kernel level abstraction from the host, if you are deploying containers, you get the additional wrapper around that application as well. So whilst some people will advocate the use of whilst you can deploy containers onto bare metal, and that's perfectly fine, typically, good practice, you would want to put containers onto a virtual machine, because then it would give you twice the level of protection. One of the other massive advantages of containers can be witnessed in agile development operations, whereby containers give you the flexibility and the efficiency to be able to develop quickly, including testing and pushing to production environments. Now you might be asking yourself, this all sounds really good. How commonplace are containers? Well, I can tell you that most big enterprises are using containers and have been for years. Furthermore, these containers that we're going to be deploying in Docker, and I'll introduce that soon, are actually transferable over to Kubernetes, which we will touch on in our later journey. Again, Kubernetes gives you all the benefits of virtual machines, plus containers, plus the benefits of the Kubernetes platform, which allows seamless failover and high availability. So whilst Docker didn't invent containers, it's certainly seen as the poster child for popularizing them. Another great feature that Docker has brought along isn't actually to do with the way it creates or runs or containers operate, but it's actually more to do with the community. I'm talking specifically about Docker Hub. Now, Docker Hub contains all of the images that run inside a container. So just stepping back into theory again, the containers I've mentioned run an image, a little bit like an ISO. That image file is built from a config. In there, it stipulates all of the different pieces of code that are required to make that container. For example, you first will specify a base image. So this could be you want to create a web server. Perhaps you will use the base Nginx container. When you do that, you'll also be able to choose what version of that image you would like. Now that isn't just software version like you would normally think, but it can equally be the platform that you're running on. For example, it can be x86 for your typical Intel AMD chips, or it could be something like ARM for your Raspberry Pi setups. One important thing to spell out is that Docker Hub isn't exclusive to Docker. Any of the images that are hosted there, you can reference with other container platforms. For example, when we move on to Kubernetes, we'll be using Containerd, which is another platform that's operated by Linux. We can still reference these exact same images. Docker also supports friendly configuration files, such as Docker Compose, which we'll be using, which puts configuration files into a much more easy to understand layout. So over the past 10 minutes, we've learned what containers are, why you'd want to use them, and some of the products that we can use to deploy them. In the next video, we'll be creating our first container by first installing Docker.